Hello. Today we're going to be looking at coastal management. So our three key takeaways are to describe the strategies that we can use to help protect the coastline, to explain how they work, and then to categorize them between hard and soft engineering. So hopefully we'll be comfortable with those by the end. Grab yourself a pen, paper, and feel free to make notes as we go through. So let's get started. So first of all, we have two different types of management, okay? We've got hard engineering and soft engineering, okay? There are examples of kind of each, how they might work in those images, but ultimately we need to look at certain characteristics that make up hard and soft engineering. So from the hard engineering, you might be able to visually see it straight away, but we have this huge wall going across, okay? In the soft engineering, we can see a few, looks like sand dunes across here, okay? This will help build up a perfect description of how these things are different from side to side. So we'll do hard engineering as more red based, okay? And then we'll do soft engineering as more green. Now these are opposing management strategies, okay, so we can use opposing ideas. So hard engineering tends to be made out of expensive materials, okay, tends to be things like concrete, sometimes wood is a cheaper form of it, sometimes rocks as well, okay, so tends to be really expensive. Whereas if we look onto the other side, oops, just amend that back. If we look onto the other side, for soft engineering, we're looking at cheaper materials. Okay, so it tends to be cheaper materials that it might just be, for example, more sand, more vegetation. Okay, so one's expensive, one is cheap. So if we continue, hard engineering, so we've got a definite change in the natural coastline. Okay, so it will amend the natural processes. Okay, they won't be the same anymore. There's a huge barrier to the sea. Okay, whereas this one, the soft engineering, tends to work with the environment. So it tends to be what we consider more environmentally friendly. So same again, we've got an opposition, we've got different materials, one's expensive, one's cheap, one amends the natural process, changes the natural coastline, one works with the environment, tends to be more environmentally friendly. So then we've got one more characteristic that we can possibly add, which would be this tends to be more effective, and potentially we can put long term. That's subject to reason, but it tends to be effective, tends to last a long period of time if it's done well. Okay, whereas if we hop over to soft engineering, this might require more maintenance, but it tends to be more sustainable. So sustainable in the long term, but requires maintenance. Okay, so potentially more maintenance. So what we need to do is now have a little look. We'll look at different strategies, and then we'll try and divide them between hard and soft engineering. So we'll clear this. So these are certain strategies that we can use on our coastline. Okay. Now, you might be able to identify a few of them, might be in your local area. These aren't all of them, but they are a few of the key ones, okay? So, first of all, up here, we've got our seawall, okay? And we can see that that stretches a vast distance, okay, along the coastline, a huge concrete wall. Okay, we can see here we've got these huge boulders. That's known as rock armor. Here we've got loads of wooden, almost like wooden embankments or barriers that go parallel or perpendicular to the coastline. So these are known as groins. Then we've got diggers look like they're dumping sand onto the beach. This is called beach nourishment or sometimes replenishment. This is adding sand sediment to the beach. Okay, and our final one down at the bottom, this is what we call managed retreat, sometimes managed realignment or coastal realignment. So we need to have a little look at how these work. Okay, so we'll add this in a different color. So first of all, sea walls. These are concrete barriers. So let's do this. Let's do this in another color. So concrete barriers to the sea to, let's put down, wave erosion. Okay, so they are strong material. So they are a strong material. Text softer rock behind. Okay, so they'll protect the area behind. They're harder than the softer material behind, so at that point we will hold the line, or we will stop the sea from retreating, or the coastline, sorry, from retreating anymore. Okay, now we've got rock armor on the far side, which works in a very similar way. Okay, so the boulders take the impact of the waves and wave energy is lost. So wave energy is lost as they impact together, leading to less erosion. Because as we said before, erosion needs power, it needs energy. Okay, so with less of that, with those boulders taking that massive hit from the waves, taking the impact, rocking from side to side, but basically taking the movement of that wave, all the power it has, the wave will have less energy and therefore it's less inclined to erode. So therefore, beach nourishment, what does that do? So for beach nourishment, we are looking at them dumping sand onto the beach, okay? So sand can be shingles, so pebbles is put on the beach, making it wider so the waves have to travel farther to get the coastline. And then gradually energy is lost during the swash. So when waves come up the beach, there tends to be a swash, this upward movement, and as all the water is trickling through the sand because it's got a greater journey to do across that beach basically acts as the barrier. So over time, beaches can lose their material when waves take them away. So what we need to do is just put it back on. So we re-widen that beach and basically have our natural barrier again to the waves. Now, groins will work in a very similar way to this. So if we can see there, there's a little zigzag shape. So those barriers actually stop any sediment moving away or down the beach. So they prevent a process called longshore drift. So groins prevents longshore drift, which moves sediment or sand along a beach. Okay. This, therefore, so we're changing the natural process with this wooden barrier, but this therefore preserves the width of the beach. So we're retaining our barrier, and they tend to be used in touristy areas as well, because people tend to like going to the beach. Okay, they want sand on the beach. Now the final one, this is managed retreat. Now this one's a little bit different. So here we can see there's a little inlet where actually they've made a breach in along the coastline, and they're taking pressure off the rising sea level by letting this land flood behind. So we can see the flood waters stretch right out to this point here, and all of this land is now lost. So all over here, this land is now lost. So what we need to put down for this one, so managed retreat accepts land will be lost and sacrifices low value land. So it will be stuff like farmland. So it sacrifices that farmland to remove pressure off other parts of the coastline. So to avoid high value, to take pressure off of high value land. Now that area behind creates a salt marsh, which is really environmentally friendly. So I'll add this in. This creates a salt marsh, which are some of the most biodiverse environments on Earth. So far we've got those strategies. We understand now, we've been through how they can protect our coastline. So the last thing we need to do is divide between, are they hard or soft engineering? Okay, so we'll clear these, move on to the next screen. So are they hard or soft? So what we'll do, we will add hard for red, soft for more green, more sustainable. Let's do that light green. So the sea wall, we are looking at hard engineering. It's made out of expensive material, concrete. It protects the area behind, but it does it in an unnatural way. Okay, so it changes the natural process along the coastline. Therefore, we can also say, or we can say for beach replenishment, this requires constant maintenance. It keeps the environment the same, so it makes a sandy beach still a sandy beach, and it tends to be cheaper. So this is soft engineering, okay, taking place. If we go over to rock armor, that is hard engineering, because we are looking at a heavy material, expensive material, and same again, we're protecting that land behind that rock, or that the rock armor. So this is changing the natural process. That coastline would have been eroded away, but it's changing that natural process, and it's very, very expensive. Changes that environment. For the groins, we can say the same. These are wooden barriers changing a natural process, so longshore drift cannot happen anymore. Okay, they're made out of wood. They might be cheaper than concrete, but they're still changing that natural process because now we can see that longshore drift that would have just taken sediment up this way, sediment is starting to collect behind these little behind the groins we can see there, starting to collect, and that's creating that zigzag shape. Okay, so that will be a form of hard engineering. So our final one, managed retreat. This tends to be cheap, not in all cases, but it tends to be much cheaper. Okay, because you're accepting land is going to be lost. It's better for the environment. So behind it, we created that salt marsh that we draw our attention to, all of this area here. So, whoops, sorry, it should be soft engineering. Soft engineering. So let's just change that color. We'll amend that to that. Okay, so managed retreat is soft engineering, better for the environment. Okay, creates this huge biodiverse habitat behind it. Tends to be cheaper, tends to be more environmentally sustainable in the long run. So our final recap before we move on. We'll clear all of this. So going back to our three key takeaways, we described, so we looked at some of the strategies that we can use. So seawalls, groins, beach replenishment or beach nourishment, rock armor, sometimes known as riprap, and managed retreat or coastal realignment. We've explained how they work. So seawall, rock armor are barriers to the sea. They take the power of the wave to avoid erosion from of the land behind them. Extending the beach, so keeping that beach nice and wide. We've got groins and beach replenishment. The longer that beach is, the further the waves have to travel, and therefore their energy will be lost before causing any more erosion. And then reducing pressure. So this is managed retreat. It takes pressure off more high value areas along the coastline. So that's managed retreat. And then we divide them hard and soft engineering. So seawall, groins, and rock armor are expensive. They change the natural processes along the coastline, and they're made from strong materials. So they're all hard engineering. Soft engineering, we've got beach replenishment, which is cheaper, more sustainable, but requires constant maintenance, but it fits in with its natural environment. And managed retreat tends to be cheaper, but works better with the environment and is more sustainable in the long run. Thank you very much for listening. Have a good day.